specifically private hardwood forests in Ontario. And I'll give you a bit of an update on where we're at in terms of developing a carbon offset project and what we've learned. And then also, because I find many people don't really understand practically how they work, I'm going to explain our perspective on how it works and how it would affect our business model. Before I begin, it's always worth giving a quick rundown on what Haliburton Forest is. If nothing else, that'll help you understand my perspective on this topic, because it's probably a little bit different than the perspective held by other people. Haliburton Forest, we always describe it as a sustainable multi-use private land stewardship company. And I always acknowledge that each one of those words could be a presentation in its own right. But I think for today, the one to emphasize is multi-use, in that we have tourism and recreation operations, we have forest products operations, and one day we may have a carbon offset project too. We own and manage about 100,000 acres of hardwood forest in central Ontario, just on the southwest corner of Algonquin Park, as shown on the map. And we're also affiliated with the ownership of an additional approximately 150,000 acres of private land, some of it closer to Huntsville, Ontario, and some of it just north of Timmins, Ontario. Our reputation as a company over the years has been to seek opportunities to add value to our property and to the products that we generate from our property. And at the same time, though, our reputation, and one that we work very hard to earn, is to uphold a strong land ethic. We're not just here for the money. We try to do the right thing by the environment, both as part of our business model, but also because it's the right thing to do. And in the context of that, adding value and upholding a land ethic, we view a carbon offset project on our property as an opportunity to create meaningful value on our property, and at the same time create or enhance the environmental benefits that our property can generate. So a bit of history on how we've progressed with the opportunity for a carbon offset project is that in 2017, we partnered with Blue Source Canada and started working with them to develop a project on our property. There had been a few attempts at developing a carbon offset project at Haliburton Forest prior to that, but they hadn't gone too far, and so this was the third time. I would say that Blue Source is a solid group to work with, and I would recommend them to anybody that's looking to do a carbon offset project. It's been a good relationship. And certainly back then in 2017, both at our end with Blue Source and everybody else that was involved, there was a lot of excitement about the opportunity to develop carbon offset projects on private forests in Ontario and more broadly across Canada. It's now interesting to look back and remember, there was a lot of excitement back then that this was finally going to happen. It was the third time, as I just mentioned, that Haliburton Forest had taken a run at developing such a project, and I think we convinced ourselves that the final law of physics is that the third time's the charm, and the third time you try something, it has to work out without any doubt. That didn't happen, obviously, and there's a couple of reasons why. The biggest one has been that the policy framework didn't develop to support a carbon offset project, but we'll get back into that later. So this experience with Blue Source is what I'll kind of draw on to explain how a project would have worked on our property and how we would have seen it rolling out and fitting within our business model. The key point that I always like to emphasize when we talk about a carbon offset project here is that foresters are, among all the regulated professionals, I would say that foresters are united in their ability to manage for a wide range of benefits. It's inherent to what we do. And our view was that a carbon offset project on our property would just be yet another benefit that we need to manage for. We already emphasize water quality, wildlife habitats, biodiversity, and other values while managing for timber production on our property. And so, it's logical to think that with a carbon offset project, we would just be formally managing for carbon storage and carbon sequestration in addition to those existing values, including timber production. it would take a lot of work, and it would probably impose limitations on the existing operations and may require some adjustments. But it would be a natural fit and a challenge that our forestry crew wouldn't have, too much difficulty accepting and integrating. What got us excited as well in terms of the opportunity of developing a carbon offset project was that we'd be better able to achieve some of the co-benefits, as they're called, on our property that complement timber growth and timber harvesting. And what I mean by that is that, by incorporating carbon storage or carbon sequestration into our planning, we'd be in a position to do an even better job of protecting the old growth stands that we protect within our property. Or by unlocking the monetary value held in the carbon that we're sequestering or storing on our property, we'd be in a better position to protect our property for many years to come from alternative uses. And I don't mean protect as in protect it from ourselves. I mean protect as in protect it from the uses that don't fit within our worldview, such as, dividing the property up into 100 pieces and selling it for cottage lots. So that's a good bridge to probably the most important topic and yet the simplest one that I want to cover today. And that's how a carbon offset project on a property like Haliburton Forest would actually work and how it would generate credits or cash. And I'm going to suggest that just assume as I speak that a carbon offset credit is an analog to cash. They're the same thing, right? Because the credit gets sold and therefore generates money. Surprisingly, few people understand how a carbon offset project actually generates money. And so I've made this really dumbed down, really simple, back of the envelope. I could have drawn it on a napkin, but instead I used Microsoft Paint sketch of how the business works. And it seems pedantic, but it's important because there's so many people who just don't quite grasp it. So I boil it down to two things. There's two ways that a carbon offset project on a private forest like Haliburton Forest can generate either credits or cash. The first way is conservation, and the second way is growth. A landowner generates credits for committing to maintain the forest stocking at a given level above the regional baseline. Okay, so that's what's known as conservation. There's a regional baseline established for what the forest stocking should be, and then the landowner commits to maintaining their stocking level at a higher level for a very long period of time, let's say 100 years, and you get paid for the difference between the two. So, for example, if the forest has, I'm making up the numbers, but 100 tons equivalent per hectare, and the regional baseline is 90, that means that the landowner is going to generate a one-time benefit of 10 tons per hectare right off the bat. Okay, so that is a really simple concept, but one that's often missed. What's important to note is that means that a carbon offset project on a property like Haliburton Forest is very skewed in terms of money generation towards the beginning, because you only get that payment once, right? You're allowed to cut your property to here, you're agreeing to maintain it here, and you get paid for that difference, but you get paid for that difference in year 1 or year 2. You don't get to keep getting paid for that. Maybe 100 years from now, once your commitment period is over, you could, flip it and do it again. But for the crediting period, that's your one-time conservation payment, and it's typically quite big, or it can be quite big, I should say. So that's with conservation dollars in the figure that I sketched out. The second way that a landowner can generate credits or cash is through growth credits. And that's the best way to capture that example, and this is what people typically think of, is that if a forest is growing, let's say, 2 offset equivalents per hectare per year, and the landowner is only harvesting 1 offset equivalent per hectare per year, you're going to generate an extra 1, right? Because the forest is growing by 2, you're harvesting 1, you can get paid for that extra bit. And that's what's called growth in the little sketch. In every single project that I am aware of, the vast majority of the credits and or the cash is generated based on conservation, not growth. Growth is a nice little income stream for the long term. Conservation is where the real value is. And that's an interesting thing to note, because the the implication of that is that if anybody's thinking of eventually developing a carbon offset project on their forest, they want to start doing good forest management today so that they increase the stocking and increase the health of their property so that when the time comes to do a project, they get to capture that conservation value. Otherwise, they're going to be dependent on the growth value, which frankly, in the Northern Hemisphere, is never going to be that lucrative. It's really going to be based on conservation. So in terms of how that would look at Haliburton Forest, I'll give you a quick snapshot. First and foremost, as I said, to earn the conservation dollars, we'd be maintaining stocking at existing levels across the property. The stocking levels would be established through the development of a very large network of permanent sample plots that would then get remeasured on a regular basis. And we'd be allowed to continue harvesting according to our management plan. But in some areas, we might end up harvesting a little bit less than we have in the past. So we were ballparking a reduction in harvest levels on our property by about 10%. Nothing crazy. And that was mostly necessary to account for natural disasters that have occurred, like beach bark disease, where the overall stocking of the property has decreased, and we would need to make up for that. Then to earn the growth dollars on top of that one-time, payment of conservation dollars, we may end up introducing longer rotations between harvests, or in some cases removing less during some harvests, depending on the structure of the forest. I mean, obviously good silviculture would still rule the roost, but where there were opportunities to be a little bit more conservative and still achieve the same silvicultural outcome, perhaps we would defer to that. In certain areas that we're already inclined to protect would probably be set aside permanently to protect their ecological integrity. A good example of that we do currently is protecting old growth stands within the property. Any old growth forest that we encounter, we typically delineate and protect, and unique forest structures. So, for example, we have a very unique red spruce stand within our property, which right now we're very delicate with, but it would probably be formalized through the development of a carbon offset project. So the overall result, if you rolled this out on our property, would be pretty much a freeze on the current stocking levels. We'd have to maintain it where we currently are, and a slight decrease in harvesting, as I said before, which is ballparked at about, let's say, 10%. And this would allow our forest to maintain that stocking, thereby earning the conservation dollars, and sequester a little bit more than we're taking out, thereby generating the growth dollars. So that's the two conventional ways that a carbon offset project plays out on a piece of private land. But there's other angles that are kind of interesting and sort of entrepreneurial and new that we're looking at now in anticipation of an eventual carbon offset project on our property. An interesting opportunity would be to meaningfully adjust the nature of our operations in order to reduce emissions. And that would be analogous to the growth dollars that I was talking about before, but not because the trees are growing faster, rather because we're reducing the greenhouse gas emissions coming out of the forest itself. Because let's all remember, forests emit greenhouse gases like CO2 and methane, as well as absorb them. They're not just they tend to be a net sink, but it goes both ways. And for clarity, and I often feel surprised I have to clarify this. I'm not talking about switching to Tesla skidders or solar-powered feller bunchers. I'm referring to, and I'm not even referring to reducing our diesel fuel consumption during harvesting operations. I'm referring to changing the nature of the operations and sometimes the timing in order to more effectively limit emissions. So the best example I can think of that we're working on right now in partnership with the University of Toronto is reducing emissions from log landings. So anybody that's been to a forest management operation will know what I'm talking about, where there's a log landing that the timber typically gets hauled to and then it gets slashed and sorted and trucked away. Those landings often end up being major emitters of methane during certain times of year. And there could be opportunities for us to adjust our harvest schedules to prevent those emissions, to limit the intensity of processing on each landing that we're using, or to rehabilitate those landings in a more carbon efficient way, let's say, to prevent them from emitting. This is a totally new concept. It hasn't, to my knowledge, been incorporated into any carbon offset project anywhere in the world. But there's real science behind it that we're working on with our partners at U of T. And the image I provided here is a good example where we have a couple of dozen landings within the property where we have soil test tubes put into them, and then researchers come out with monitoring equipment to read the gas flux from those landings, so that over time we can figure out how to reduce those emissions. So that's the real quick and dirty of a summary of how a carbon offset project would work on our property. It's definitely back of the envelope, and I probably made it sound a little bit too much like easy money, right? You partner up with somebody, you stop, you don't deplete your forest, you let it grow a little bit more, you change your harvest schedule, boom, a couple $1 million, you're good. It's not quite that way. I'm obviously simplifying it. And I think it's very important that everybody, especially on the forest product side of it, are very clear about the fact that this is not easy money. A carbon offset project takes a lot of work, and more than anything else, it's a huge commitment for a landowner to undertake. At Halliburton Forest, entering a carbon offset project would entail very meaningful sacrifices, both operational and financial. We would be sacrificing the ability to set higher harvest rates, which is very much our right now. We'd be sacrificing the ability to deviate from sustainable management, which, while it's not our inclination, it is our right to do that. And we'd be giving up the opportunity to develop our property at some point in the future. And again, that's not really our inclination either. I have no ambitions of seeing golf courses spread throughout Halliburton Forest, but it is our right to do that. And we would be legally bound, effectively in perpetuity, to be maintaining a healthy, productive forest forever. It just so happens that is congruent with our objectives today. My colleagues and I believe in that. That's why we're here, and that's why we work together. But it does entail a financial sacrifice on our part to give up the right to do any of those things, particularly if at some point in the future we wanted to sell the property or sell parts of the property. And so in other words, the existence of a carbon offset project would effectively be an encumbrance on the property, which significantly reduces its value. So I mention all that not to say that one shouldn't, participate in a carbon offset project, but rather to say that anybody that sees it as a free lunch is incorrect for two reasons. The first is because they either don't appreciate the significance of the commitments that are being made under a carbon offset project, or more importantly, they take sustainable forestry on private land for granted. And that's the one that I think the forestry community needs to watch out for, where people will generally assume that we are bound to manage our forests in a certain sustainable manner, forgetting that it's a landowner's right to do what a landowner wants with their property within the scope of, environmental bylaws, regional bylaws, and provincial policy, but that we are free to do what we think is best with our land. And that's a very important point. There's an annotation request that just popped up, which I'm going to decline because I don't know what it is. We'll see what it is later. So having made that point, I'll just turn to our project development timeline and kind of wrap up. As I mentioned earlier, the markets for carbon offset projects in Ontario did not develop as quickly or as robustly as we were hoping back in 2017. That doesn't faze us too much, though. The commitment period for a carbon offset project that we would likely enter into is going to be 100 years or longer. And that's pretty much what our forest management planning window is right now anyway. We kind of think in terms of the average mature tree. And around here, that's about 120 to 140 years. And the terms of a commitment under a carbon offset project would be registered on title with our property. So once we commit, there's really no going back. That means that the repercussions of the decisions that my colleagues and I make with respect to a carbon offset project on our property, it's going to be felt by our successors for the next couple of generations, right? 100 to 150 years from now. And that means that we're in no particular huge rush to get into a project. It's such a big commitment that it's worth taking the time to plan it out. And the best way to kind of rationalize that from a forester's perspective is that the time period between the commitment that we make under a carbon offset project and the end of the crediting period is greater than the time between the photo here and today, right? So not that long ago, let's all remember, sustainable forestry didn't exist in Ontario, and we were doing this kind of thing, basically recovering as much wood as we could, as cheaply as we could out of the woods. And professional forestry evolved over that period. We think that that's a long time ago, but it's really not that long in the context of a carbon offset project that is going to be 100 years minimum, if not potentially longer, unless, of course, you go voluntary, in which case it would be shorter. Anyway, my point is that by committing to develop carbon offset projects, it'll probably be one of the biggest decisions that my colleagues and I make in our careers with respect to this forest, at least as big as the decisions that go into each management plan, but realistically a whole lot bigger because it's almost a paradigm shift in how this property will function in the future. And we're okay playing the long game with that in mind. And in the meantime, taking opportunities to learn more about how an offset project could work on our property and what creative entrepreneurial aspects could be added to a project, such as limiting emissions from some logging operations. So that's the crash course in carbon offset projects at Halliburton Forest. I'm sure there will be questions, and I will be happy to take them when the time comes.
Okay, thank you very much, Malcolm. And I've noted the questions are showing up in the chat, which is great, and we will address them at the end. And I can tell from the what we're talking about who that they're actually going to. So before we move on to Bob, I noticed that Tony Bull is in, and since the Eastern Ontario Model Forest is graciously hosting this talk this morning, I'd like to pass the microphone over to Tony, and he can give his welcome and a little bit about the Eastern Ontario Model Forest. Tony? Hopefully you're there.
Can you hear me?
Yes, we can hear you now.
Okay. Listen, I'm sorry I wasn't here right at the start. I had to stop everything and get it going again. I'd just like to say a couple of things. And that is, and Malcolm was talking about that in his presentation, what I was reading and helping me understand what we wanted to do with this was that the two big environmental problems we face on this planet today, and one of them is carbon dioxide warming, and the other is the impact on biodiversity of human actions on this planet. And people have read, I'm quite sure, about the accelerated extinction rate of species because of the destruction of biodiversity and habitat. And so the people we've got speaking today, Malcolm on the carbon side, Bob later on, talking about how he's managing his farm. And there's a term that I came across in reading about this called restorative agriculture. And he's practicing that, and you'll hear him talk about what that means in terms of the biodiversity values on his farm. And just a couple of words about the Eastern Ontario Model Forest for those who are on this line and don't know us. We have two or three big business lines. One is sustainable forest management by means of holding our Certificate on Forest Stewardship Council Sustainable Forest certification over several tens of thousands of hectares of land across eastern and southern Ontario, county forests and private woodlots such as our own, mine, and Ann. And we're also in the forest health business through the Forest Health Network, sharing that. And that reaches down into northern New York State as well, Cornell University, because of the march northward of threats to our forests seems to be inexorable. And intertwined with all that is the educational things that we do, such as this seminar and our winter forest seminar. But we hold events for all the people who are certified forest managers, And we're allied with the Ontario Woodlot Association chapters across Southern Ontario as partners in the Forest Health Network as well as all the communities in Eastern Ontario. So we're in the education business as well. And that's all I will say.
Thank you, Tony. Okay, great. So I'm glad we were able to get that in. Now it's my pleasure to introduce Bob Dobson, who's going to talk to us about forest farms, how forest farms can help in conserving biodiversity. So a little bit about Bob. He's a great-grandfather, started farming near Cobden. So Bob's great-grandfather, sorry, I don't know if Bob is a great-grandfather, that's another story, but Bob's great-grandfather started farming near Cobden in the 1830s. It's been in the Dobson family ever since. Bob has served on the board of the Ontario Cattlemen's Association and one term as president. He also serves on the board of directors of the Canadian Cattlemen's Association as chair of the Environmental and Animal Care Committee. In 1994, Bob was the first recipient of the Ontario Cattlemen's Association's Environmental Stewardship Award. This was in recognition of Bob's project on the farm to enhance and protect waterways as well as create bird and wildlife habitat. In 2003, he was inducted into the Renfrew County Agriculture Hall of Fame. Please join me in welcoming Bob Dobson.
Yes, thank you very much. I'm quite pleased to be able to speak for a few minutes today about some of the environmental projects we've completed on the farm over the last 40 years or so that I've been managing. I can click. Nope, it doesn't work. Oh, yeah. All right. So I don't need to introduce myself too much anymore. I did complete 3 years at Kempel Agricultural College and graduated in 1962. And Kempel College, as you know, disappeared about 5 years ago on the chopping block of the provincial government. And but anyhow, the map that you see in front of you on the right was a class project while I was in college. I think it was probably from 1962, and I named the farm Laurentian View Farms. We're in Laurentian County. We're in not Laurentian County, Laurentian Township, and in the corner of that township. This map that you see in front of you gives a better idea of some of the tree plantings that we have completed over the last 40 years. The strips in green will show basically the upland shelter belts, for the most part planted across the prevailing wind, which comes, of course, from the west and the northwest. Here, the lines in blue, I call them lowland rather than highland. They're lowland riparian buffer strips. And there are about 2 miles of each of those strips. Those strips will be anywhere from 2 to 5 and sometimes 6, 7 rows wide. So along the stream, they are wider probably than on the banks of the stream spreading across the farm, the two streams, and to protect the water. I started planting a few trees in the late 70s when I came back to the farm. And by 1980, I got up to about 1,000 trees a year or more. I tried to have 1,000 trees a year survive on the farm, planted in these various areas, and continued that until about 10 years ago, 2010. Backed off a bit, haven't planted as much since then. Hope to continue planting for a few more years. There's a few other areas of the farm I'd like to get reforested. Why is our farm called Dobson's grass-fed beef? Why are we a grassland farm? Well, 50% of our land here, our 200 acres, is rural. And I put this slide in on the left just giving you an idea about topsoil. This row of trees, it's a shelter belt, probably about six rows wide of spruce on the west side and white spruce and red pine on the east side. Kind of protects the farm buildings. It runs for 500, 600, 700 feet or something. It's now about 30, almost 40 years old. And the trees at the bottom of the hill, we have put a couple lines on there, at the bottom of the hill have twice the volume or twice the size diameter of the trunks and the height. And you can see the line at the top shows they're all about the same. It looks like they're the same height. The difference is topsoil. If we did not keep our land covered, at least 50% of it, we would have tremendous erosion. So we chose back a few years ago to just, well, actually 25 years ago now, nothing's been cultivated on the farm. That's all covered, permanently covered in grass and legumes. All of a couple slides on the right showing cutting hay and drawing hay in from the field. All of our beef is sold direct to consumers in the Ottawa Valley, from Orleans to Deep River, pretty much strip along the Ottawa River. We planted, as I mentioned earlier, we planted a couple miles of upland shelter belts. Here are a couple of examples. And the example on the left is about 30 years old, approximately, and we are experimenting a bit. I guess it's kind of a work in progress with what type of shelter belt makes the most sense or gives us the most benefit, the kind of benefits that we want to see. And the benefits we're talking about is wildlife, water retention, soil erosion, wind protection for wildlife, and for our animals. Our beef animals are generally outside year-round. So the example on the left is showing 2 rows of cedar about 5 meters apart, and down the middle of the row of cedar is a row of white ash. We'll see what happens to the ash trees in the next few years, but they attained about twice the height of the cedar. Pretty good shelter. This is near the buildings, so the cattle use this shelter in the wintertime quite a bit when they are in that area. And the slide on the left is also a couple of rows of white cedar, the slide on the right, and a row of white spruce down the middle. Pretty good windbreak shelter also. A couple more before we move on. We planted a lot of oak trees on the farm, in red oak and some white oak. I guess the other species I forgot to mention, but we plant quite a lot of white spruce, red pine, as you saw earlier, cedar, ash trees, although we may not plant any more ash trees for a while, butternut, black walnut, tamarack, maple. A couple of, the picture on the left is showing a couple of fairly narrow shelter belts. The left of the picture on the left is oak and cedar. You can't see the cedar too much. It's pretty coming along the bottom. The right of that picture is a row of red oak, I believe. The other picture on the right, the other slide on the right, is just showing one row of red oak along the bottom of the hill beside a hayfield. And to the left of the row of oak, there's a bird box in the front of that picture, by the way. I guess is about 2 acres of that's heavily infested or heavily grown in hawthorn trees that we like to keep there because that provides a lounge area and a resting and shade area for our livestock and pasture for about 100 fields or access from this 2 acres, the central watering area. So going back a few years, this picture, this slide, I apologize, it's a bit fuzzy or hazy. I don't have very many before pictures. This picture was taken a couple of years after I came back to the farm, and we had been quite concerned with the water quality. Also, we were starting to run short of water. Quantity was down. And I started to fence the cattle out of the stream. And this picture was taken a couple of years after that. We first put the fence right along 1 meter from the edge of the water. And within a couple of years, you can see there's very little woody vegetation trees along the stream. Cattle access over the years had pretty much kept any trees or shrub growth down to almost zero. A few dogwood in here, they survived. This is what took place over the next few years. The end of the 1980s, 87, 88, we dug a cattle impoundment, a water impoundment reservoir pond. This was done in a dry part of the year, I guess. And the water from the creek would flow through the pond. That's on the top left photo. And we planted trees and shrubs on both sides of that pond, and actually right across the whole farm. The cattle needed water. Once we got the cattle fence out of the creek, the cattle needed water, needed a good source of drinking water. So the photo in the middle on the bottom is a small photo. There's a couple more on here too, of an inline gravity trough system. That was one of our first alternative water systems. That's located at the bottom end of this reservoir pond. And the cattle walk down the bank in that very small restricted area, stick their heads over the edge of the trough, and take their water without putting a foot into the stream and without degrading the water. We planted approximately, I had said earlier, a mile of lowland buffer strips on each side of the stream. This you'll notice in the right picture, the top right picture, it says 2010. I think that's about the year that was taken. That's the same stream. About 25 years later, we are finding this water quality and quantity quite good. This year, we sometimes ran out. We occasionally run out, I guess, in a dry period. And next slide. So this is the pond as it looked a couple of days ago. I took this picture last Sunday, actually. You see a bit of snow in the foreground. And you will notice that we have hardwood trees. They're white ash, again, white ash trees along the left side of the bank of the big impoundment pond. This pond is about 1,000 feet long. And we have, beside that white spruce, we have some butternut, I guess black walnut trees, a few butternut trees too. And on the right side, we have quite a lot of cedar planted, the whole length, and about 25 feet from the edge of the water. High-bush cranberry we plant along the stream. Nannyberry we tend to plant up in higher ground, but high-bush cranberry and elderberry we planted quite a few. This is to give you a better idea of our first attempt at creating an alternative watering system, the first solution. Because once we started to get the cattle fenced out of the stream, we needed a good we needed a really good, reliable water system. So the next slide. Yeah. So now, I want to share with you, just get it set up, please. I want to share with you just a 30-second video that I took a couple of days ago. And I think this video quite nicely sums up the direction that we've tried to move the farm in the last 40 years or 42 years or so. And our main focus being clean water, cleaner water, cleaning up the water. Okay, so that's a little video, the 30-second video. I just thought it was when I was back near the stream the other day, that was a good. It always amazes me how clean the water is now with the buffer strips along the banks and the trees and shrub planting. Oh. Yeah, we're just getting this moved ahead here. Oh, sorry. So the water depends on the trees and shrubs. The other thing I wanted to mention was we had an interesting group from, well, actually about 4 or 5 years ago, we had a couple of groups of visitors came in from mainland China. And it was quite interesting. I tried to focus on the tree planting and the buffer strips because I felt maybe they have some issues with water quality and floods in China. And it was interesting to get them down on the ground and look at where these, generally there's a lot of 1-foot diameter trees, and it's cracking open our clay soils, which is allowing any major rainfall, a couple of inches or more, sometimes you get that, or runoff from the fields to penetrate into the ground. This picture just is the same inline gravity feed water system. On the left, 1987. The right is 2016. Couple of arrows here. Those would be the same location of the farm on the farm. Separated by about 30 trees. You will note the buffer strip is kind of feeding into the upland shelter belt. They're all connected now, and the landscape is quite changed over that 30 years. Another alternative watering system we have on the farm would be called a low-level crossing. Basically, it's just normally constructed at some hard surface. We chose to lay a strip of cement down, and that needs to be at the same level as the stream, so it does not impede any flow of aquatic life up or down the stream. It's not normally, I think, that great for a large herd of cattle. We use it as a way to get cattle back and forth across the stream without doing any siltation. Occasionally, it can be used for a short-term water system, and if there's no shade around it, like large trees shading it, they don't seem to linger very long there on the hard surface. Another system that we installed as an alternative, because the farm is stretched out and the whole farm is rotated back and forth between hay and pasture fields, so we need lots of water outlets. But we installed a solar pumping system back in 1994, and it's still working well. Same solar panels, change the batteries every couple of years, every 6 or 7 years, I guess, the two 12-volt batteries. And the pump we replaced about 5 years ago after 20 years. Most of this system is underground, And the water comes from the pump located near the pond that you see in the left picture all the way across the farm, 600 feet, and shoves it up about 20 feet to that 2 acres of elderberry plantation, the lounge, resting, shade area for the animals. And this big trough holds about 1,000 gallons of water. It was poured in 94. It still looks the same as when we constructed the trough. It's a large trough, so when we've had as many as 100 head of cattle coming to drink. They all want to drink at the same time when they're coming from a distant grazing field. So we needed to have a large volume in front of them so they all get enough water. At the bottom left corner of that big cement trough is a electronic float. The cattle tell the system when to come on. When they drink the trough half, the pump comes on automatically and fills it up rather quickly. Just another picture of the solar pond that we're pumping the water out of. This shows the progress of trees and shrubs along the pond. The solar pond, that pond, by the way, is about 14 feet deep. We had a high hole in to dig the pond, and we hit fractured limestone. The water started pouring through. We constructed on 50% of the area around the pond a land dike, I guess, or a land dike. We excavated the soil, got an overflow pipe in, and very quickly it held. And now, almost 30 years later, 26 years later or so, it's still working very well. Okay. And the second solar system was put in as on the large impoundment that you saw a couple of pictures earlier. In 2012, we had a very severe drought, and our inline gravity-fed water system dried up. We still had a couple of meters of water in the pond, but we had to get it up to the cattle. So the second solar system was put in then. This picture, we're just about near the end. This picture is just a couple of views of the farm that, you know, those people come across every once in a while with the airplanes and take photos of farmsteads and then come and sell you the pictures. And I guess I bought a couple of prints. The one on the left shows 1982, and we're just kind of getting nicely into planting trees and shrubs. The one on the right was taken 2015, shows what that number of decades of planting trees can change the landscape into. Technical situation. Oh, yeah. Okay. So this, I think, is maybe the last slide. I stuck a couple of these in to show that we've been asked to share some of the things that we've done in the farm that people thought were interesting. And through the 80s and the 90s, we hosted quite a number of farm tours. Come in, talked about the environment and what we're doing to improve our footprint on the environment on our own little piece of land. And once we got into 2000, we started our business of selling grass-fed beef direct. That's been operating for about 17 years now. We tend to get more visitors from the city. They want to come in and see where their food comes from, and there's a certain number would like to know how it's produced. And I have to say that we have a website, and we spend put a bit of space on our website through the environmental projects that we've completed over the years. And for first-time purchasers of our product, grass-fed beef, we have quite a lot of people mention our environmental footprint as the reason for giving us a chance, at least the first time. If the product is up to their satisfaction, we keep getting business from them. But the environment, I never thought that it might pay in that respect. Well, I never thought that we would be retailing our beef directly. Prior to 17 years ago, all of the beef production from the farm was marketed as a commodity. We have probably had 200 tours over the 40 years or so on the farm. We've had, in the last few years, we have exchange, people come in on an exchange program called WOOF Canada. It operates around the world. They come in and spend a couple of weeks to a couple of months on the farm as part of a working holiday. The last dozen years, we've had a number of agricultural school interns from France come and spend time on the farm. So my last thoughts, I guess, before I wind up in about 30 seconds, would be that various issues arise over time and different challenges emerge. And we saw from the last presentation I was quite interested in, fixing carbon sequestration. The trees on our farm, perhaps they're doing a bit of that, but we have planted them to hoping that they do a lot, quite a bit more. An example I wanted to give, though, of changes, that when I was growing up in the 50s on this farm, and my dad was operating the farm, of course, farmers were being encouraged to clear out scrubby fence rows and make more room for crops, become more efficient, and drain the swamps. Drain the wetlands. So I read the other day a story in the farm paper to say that 75% of the land in southern Ontario, the wetlands are gone, and perhaps it's time to start managing wetlands a little better. My dad, in the 1950s, I think he did anyhow. I know there were financial incentives from agricultural ministries and departments to clear out fence rows. Now there are some financial incentives from programs like the Environmental Farm Program that came out in the mid-90s, and the ALICE program, Alternative Land Use Services, to help to put fence rows back in, buy trees and plant trees and shrubs. Anyhow, I think that's about long enough. So thank you very much. Plant more trees.
Thanks very much, Bob, and that's a great one to finish up on. Thank you very much for your talk. And now, without any further ado, I'd like to move on to a presentation called Quick Overview of Climate Change and Related CFS, Canadian Forest Service Tools for Forest Adaptation, and that will be brought to us by John Pedler. The two scientists involved in doing this work are Dan McKenney, who's the team leader for this type of work. He's the senior scientist and team leader, and he works basically on economics and ecology. But we are happy to have John Pedler here, who will talk to us about this project. And John has a BSc from University of Guelph and a master's from Carleton University. Since 1999, he's been employed as a forest landscape biologist at the Great Lakes Forestry Centres in Sault Ste. Marie, which is part of the Canadian Forest Service, Natural Resources Canada. His work focuses on how climate change and invasive species impact forest ecosystems and related socioeconomic values. Today, he will be talking about the tools that assist in the forest regeneration decisions and climate change and a changing climate. John, take it away. And you're on mute. Still on mute.
Okay, can you hear me now?
Yes, I can hear you now.
Okay, good. Sorry about that. Now I will just get my... Okay. All right. Well, thank you for the introduction, Joseph, and thanks to Ken Farr for inviting me to talk today, and to Astrid for making all the technology work. So today I'll give you an overview of climate change and some related tools that we've been developing for forest adaptation. I work in a group at the Great Lakes Forestry Center in Sault Ste. Marie. It's a multidisciplinary group, and we've recently been renamed as the Integrated Ecology and Economics section. So spatial climate data, or essentially maps, is the foundation of much of the work that we do. And that spatial data drives research topics such as plant hardiness, species distribution modeling, invasive species studies, and climate change impacts and adaptations. So today I'm going to give you a brief overview of climate change at national and regional scales, and then talk about some of these tools that we're developing. So all signs are pointing towards climate change happening. Over the past 100 years or so in Canada, we've had a 1 degree Celsius, approximately a 1 degree Celsius increase in mean annual temperature. And that's strongest warmings occurring in the west and the far northern part of the country. So these maps shown here are showing the projected change in mean annual temperature for the country. The top map is under a low emission scenario called RCP 2.6, and the bottom map is under a higher emission scenario called RCP 8.5. You can see under the low emission scenario, the projected changes are between about 1 and 3 degrees Celsius across the country, again with the strongest warming happening in the north. And under the high emission scenario, the changes are between about 5 and 9 degrees Celsius, again focused in the north. But in the eastern Ontario part of the world, I think that's the Pembroke region that I have blown up there on the right-hand side of the screen, the expectation is for about a 4.3 degrees Celsius increase in mean annual temperature by the mid to later part of the century. And I just want to draw your attention to that graph in the lower right portion of the slide. I'm talking about sort of mean changes, but it's important to remember that there's a lot of annual variation still in terms of the temperatures that we're going to experience. So there'll still be warm years and cooler years, but by about halfway through the century, even the cooler years are expected to be warmer than what we sort of experience as a warmer year currently and historically. As far as precipitation goes, under the low emission scenario, increases across the country between about 0 and 20% increase in precipitation projected. Under the higher emission scenario, increases are as high as 50% in the far north. And in eastern Ontario, we're projecting about a 9% increase in precipitation. And again, with lots of variability there with dry years and wet years expected. So the last couple of slides have suggested an increase in temperature and an increase in precipitation. So how does that all net out in terms of dryness, which is, of course, an important thing for trees and forests? And we look at this using a measure called the Climate Moisture Index, which is basically a balance between how much precipitation comes in and how much evapotranspiration goes out. Positive values suggest you're getting more precipitation than evapotranspiration. So these maps show climate moisture index for 4 different time periods, sort of a current time period, and then each of 3 future time periods under RCP 8.5. And sort of the answer to that question of how does the moisture balance net out? Well, it looks like it's projecting a drier future for Canada. There's a lot more sort of yellow and red on the map as you go through time. And I've written the CMI, expected CMI value, again in eastern Ontario in the lower right corner of each map. And I draw your attention in particular to the value for the final time period, which is a value of 3.3 centimeters as a measure for CMI. that was a bit of an eye-opener to me, because we have a scientist out in Western Canada named Ted Hogg, who's done a lot of work on this CMI metric, and he's found that sort of the cutoff CMI for supporting forests is 0. And if you get below 0, you get into a situation where it's sort of aspen parkland and prairie type situation. So, I mean, I know it's sort of an extreme example and it's several decades down the road, but it was a bit of an eye-opener to me to see that it could be a struggle in some parts of Eastern Ontario to be maintaining forests on the landscape towards the end of the century. It kind of put into perspective the kind of challenges that forest managers might have to deal with. So what do these changes mean for forests? Well, I like to think of it in terms of direct and indirect impacts. In terms of direct impacts, we'd certainly expect some impacts on growth. And I guess if there's any bright side to climate change, we might expect to see some growth increases as well as decreases. Canada is a northern cold country, and much plant growth in our country is limited by cold temperatures. So we would expect to see some increases in some areas, likely somewhat short-lived if we get into some of those high climate change scenarios. We'd also expect to see some mortality in response to extreme climatic events such as droughts, late spring freezes, floods, and wind events. And there's also reports suggesting that we could see some reproductive declines, and that may already be happening related to seed and seedling problems and sort of busts in some years as far as flowering goes, and as far as seed success. So as far as indirect impacts, I'm talking about impacts that climate change has on disturbance regimes that in turn impact the forest. So a big one here is, of course, fire. And I'm reporting on some work here by Jan Belanger and Sylvie Gauthier in our Laurentian Forestry Center. And the large map at the top shows annual area burned in fire zones across the country. And so the warmer colors, the reds and the oranges, the red colors are areas that get a lot of fire. Northwestern Ontario, across the northern part of the prairie provinces, we've got annual area burned greater than 1% in those regions. In Eastern Ontario, fire is not such a big driver. It's sort of less than 0.1% per year being burned in that area currently. But under climate change, that bottom row of map is showing changes to those fire regimes in terms of a ratio increase. So any of the zones showing up as red have like a 4 times increase in the amount of annual area burned. So something like that zone that's called LW in the top map is already a zone that's getting a lot of fire each year. And in the future, it's supposed to get 4 times that. So that's really quite a concerning situation for that area. That would be, again, getting into a situation where it may be challenging to keep trees on the landscape with that rate of burning. In Eastern Ontario, the projection is for an increase of around, 1 to maybe 2 times the current rate. So likely not as much of a concern, again, on the fire front in your region. I think a real dark horse with climate change impacts is the response of forest pests to climate change. I guess we have to look no further than the sort of havoc that's been wreaked on western forests by the mountain pine beetle to see that. And there's certainly been some interest in terms of figuring out if the mountain pine beetle will be able to cross the northern boreal and make it over to eastern forests. It looks like that may happen eventually. But another beetle that can cause problems and that's maybe been flying under the radar is the southern pine beetle, which is a problem for pine forests in the southern U.S. But according to our climate projections, it looks like there could be suitable climate for it in eastern Canada in the next 30 years or so. So something to keep our eyes open for. All right, well, that hopefully gives you a quick overview of climate change on sort of a national scale and also at a more regional level. It's never a really uplifting topic, but it's one that we do have to kind of stay on top of and stay aware of. So I want to change gears now and talk about some climate change adaptation tools that we're developing at the Canadian Forest Service. These tools have been developed for the most part as part of a program called the Forest Change Program. And one of the outputs of that program is an adaptation toolkit that focuses on developing adaptation tools. So all these resources can be accessed at the link that I provide below. So a key climate change adaptation tool is assisted migration. I'm sure many of you have heard about this, but if you haven't, it's this notion of moving organisms or populations to locations that are outside their traditional boundaries in response to climate change. It's a topic that's received a lot of attention in the last 10 to 15 years, but it's actually been around since about 1985, when an article in Bioscience really kind of hit the nail on the head and identified the possibility that organisms may need to be moved to track climate conditions, and pointed out that it's going to be a complex process and that applicable technologies would have to be developed. So that's really sort of exactly what we've been working on in our group. And I'd just like to point out that there's also different types of assisted migration that are recognized sort of along a gradient of movement distances. So sort of the most benign type of assisted migration is moving genetic material populations within the current species range. It's called assisted gene flow or assisted population migration. Then you've got an assisted range expansion, where you're actually moving species modestly beyond their current range limits, maybe in an effort to sort of mimic natural migration. And this is being considered for ponderosa pine, moving it into southern Alberta and central Alberta. And then there's long-range assisted migration. An example of that would be movements that are being undertaken for the endangered species called Torreya taxifolia by a group called the Torreya Guardians. And they are moving seeds and seedlings northward into entirely different ecosystems than where it's currently found, thousands of kilometers northward into places like Michigan. So one of the tools that we've been working on to assist with assisted migration is called Seedware. Some of you may have heard of it, but it's a web application that essentially is a climate matching application. So it identifies locations with similar climate to a point of interest. We use something called a Gower index to calculate that climate similarity, and it can be calculated using any number of climate variables of choice. And we've developed the application to incorporate climate change. So in this top map shown here, I'm showing Petawawa Research Forest, and the warmer colors indicate locations that have climate that's similar to that location. Sort of in a non-climate change world, those might be places where you'd consider getting seed sources to plant at Petawawa. The bottom map shows that same analysis, but taking climate change into account. So we're no longer matching the current conditions at Petawawa, but the expected future conditions in about 30 years, and identifying potential seed sources that could be planted now and that would be well matched to the growing conditions of that plantation, in about 20 to 30 to 40 years. So that's how Seedware works, and it's been a useful tool, but it doesn't help, or maybe it raises the question of, well, how similar is similar enough? That index ranges from 0 to 1, so I mean, is it okay to move species or move seed sources that are similar at a value of 0.9, so the orange color on that previous map, or is it okay to move them from the yellow region? So to get at answers to those questions, we've pulled together provenance data from a number of sources, and we've calculated what are called critical seed transfer distances. This is work that's following on from a concept developed by Greg O'Neill and colleagues out in British Columbia. And basically what we're doing is, with this provenance data, is we're generating transfer functions. So that graph at the top right side of the page shows a transfer function, and what it's showing is the relationship between how well seed sources grow on the y-axis and how far they've been moved to be planted at the test site. So the vertical black line, sort of in the somewhat middle of that downward shaping parabola, is the local seed source. Any movements to the left of that are northward movements, and any movements to the right of that are southward movements. And so that dashed red line, or the red lines on that graph, are showing that you could move things northward almost 4 degrees Celsius and still have growth that's going to be within about 95% of the local seed source. Alternatively, you could move things southward about 2 degrees and again achieve that 95% growth limit. So that's the way that critical seed transfer distances work. They also can be mapped somewhat similarly to the seedware map, and you can identify limits, and these are limits now that are sort of based in gene ecology for how far you can do these seed transfers. So we did this for 5 different tree species, and we've submitted that work to the Journal of Ecology. And I just very briefly want to go over some of the results. You know, a lot of time as researchers, negative results aren't what you want, but I think in this case they're interesting. First of all, a lot of the transfer functions weren't significant at test sites. For many of these species, less than 50% of the transfer functions were significant. Secondly, in cases where they were significant, the R-squares were quite low, suggesting weak relationships and sort of noisy data. And finally, again, in the case where we could calculate critical seed transfer distances, they were quite large. So, I mean, I tend to think in terms of mean annual temperature. So if we look at some of the mean annual temperature northward transfers there for black spruce, it's suggesting you can move it about 5 degrees Celsius northward and still have good growth. Same with white spruce, same with jack pine, even further for white pine, nearly 8 degrees Celsius northward movements and still getting good growth. And quite high value for yellow birch as well. So on the plus side, as far as seed transfer systems go, this would suggest that you can have relatively coarse and flexible systems. You don't have to worry about tracking seed movements down to the nearest 10 meters or anything. You can have large spatial units in your seed transfer system. But on the other hand, it does raise some concerns about the capacity of assisted gene flow to address climate change concerns. There isn't that really strong, we're not finding anyway, that really strong connection to climate that would suggest, a lot of power in terms of moving seeds to address climate change. Some of you may be aware that Ontario recently updated their Ontario seed transfer systems, and I just wanted to point out that we were, happy to collaborate. It was a nice collaboration with the folks at OMNRF, and they've managed to transform their static seed zone, shown in the top map, to a focal zone system, shown in the bottom map, that identifies sort of a unique set of potential seed sources for any given planting site or planting zone. And that analysis is underlain or supported by the seedware and critical seed transfer distance work that I showed in the previous 2 slides. Okay, I just wanted to briefly talk about a couple tools that are being developed in CFS that are outside our group. The Forest Vulnerability Assessment tool has been developed by Isabelle Aubin and Laura Boisvert-Marsh at GLFC, and this is a tool that is essentially a map that you can click on and then provides for the location that you've selected species that are there and their sensitivity to drought. And that drought sensitivity is based on tree traits such as rooting habit and xylem characteristics. And the last tool I wanted to mention is the Adaptive Silviculture for Climate Change, or ASK trial, going on at the Petawawa Research Forest. This ASK program aims to create a multi-region study, and it really wants to demonstrate climate change adaptation in action. That's the goal of that study. And PRF is the 6th ASK site and the first to be developed outside the United States. And it's headed up by Mike Hopeting, Jeff Fair, and Trevor Jones at the Canadian Wood Fiber Center, and they're working closely with the 3 women pictured here to really head up the program on the U.S. side. So these ASK trials require that you put in treatments that sort of address resistance, resilience, and transition, and that's sort of along a gradient of strength of climate change response, or climate change adaptation response. So some of the treatments at PRF include for resistance, which is pretty modest kind of response, talking about sticking with the standard harvest, shelter wood harvest system, but incorporating some of those within range seed movements. So a pretty mild climate change adaptation approach. With resilience, they're going to introduce a different harvest system called an irregular gap shelter wood harvest. And again, with featuring within range seed movements on the regen side, but for a wider range of species. And finally, with transition, where they're really trying to clear the way for a whole new forest type that would be better adapted to climate change, to future climate conditions. They're talking about clear cutting, leaving about 10% residual forest, and much more aggressive species movements, including species such as pitch pine from the United States being incorporated. Okay, so just in summary, I did a brief overview there. We see that temperatures and precipitation are expected to increase, but likely overall a drier future for much of the country. And, we have these adaptation tools that are being developed, and are happy to get collaborations and to get feedback on them. And the ASK experiment at PRF, I just wanted you to be aware that we are thinking sort of beyond just assisted migration and thinking about some more aggressive climate change adaptation responses. So thank you.
Okay, thank you very much, John. That was very informative and very good. Okay, so by my clock, we got like 3 minutes left, and I see we have way more than 3 minutes worth of questions here. So we will try. I'll pick a question and we'll try to give it a shot, and we'll see how we do with it. We may or may not go over. I don't want to take more people's time, and then people may have other stuff scheduled, and including our speakers. So, and I need to give some time here to Astrid because we have people to thank for this. First of all, I would like to thank our speakers. Thank you very much. This was very much an experiment for us, and this is a lot of really good information. So without any further ado, I'm going to choose one of the questions. We've all seen them here. So the one question I can see right here from Victor Burnett is asking to Malcolm, is the decision of the province concerning carbon trading impacting on the project that you're working on?
I'll keep the answer short. The answer is yes. There isn't a compliance protocol in effect in Ontario, so that was the provincial government's decision. Obviously, when the government changed a couple of years ago, we're one to want to develop a carbon offset project right now in Ontario. You would do it under a voluntary protocol, which has different terms and frankly different values to the compliance one. So yeah, provincial policy is a major driver of the opportunity for these things, and we remain optimistic that in the fullness of time there will be an opportunity again to develop a project.
Okay, thank you. Listen, we'll try to get answers to the other questions because they're all very good. Astrid, over to you. You want to be able to close up here, and we've got about a minute and a half to do that. So over to you. And you're on mute.
I know that. Okay, thanks, Joseph. I just wanted to take a minute to thank everybody, in particular the speakers, for their excellent presentations today. They were great, and I'm sure I speak on behalf of everyone saying that we learned lots from you in terms of what's being done out there, and I think a lot of really applicable tools that you provided us and ideas, so thank you for that. And special thank you also to the volunteers who have put this together. This would not happen without them. They do essentially everything to make sure that things happen the way they do. And the team this year is Tony Bull, and he's been spearheading this for many years. So thank you, Tony, for all your hard work on this. And as well, Ken Farr and Joseph Anawati, thank you for your moderating today. And then a new member, Nancy Admirat, that joined us this year. So it's nice to see a new face joining the team. So thank you. And as you know, we wish that we could see you in person. I'd rather have a 3D than a 2D event, but I think all things considered, this is certainly a good alternative and a way that we can still connect. And so on behalf of the Eastern Ontario Model Force, we wish you a happy, safe holiday season, and we look forward to being able to share a lovely holiday meal at next year's event. So thank you, everyone. Take care.
Thanks, everybody, and thank you very much.
I meant to tell everybody that the presentation will be, has been recorded, so if I can figure out how to get it up on the website, I'll do that.
Ashley, what are we going to do about the questions? Can we send each question to the specific presenters and have them answer it, and then now